Hi everyone, welcome back with this video. So in this video, we'll be doing one practical of the text classification. So as of now, we have learned about text preprocessing and text representation technique, like how we can convert our textual data to numerical representation. That means the vectorization, right? So we'll be using all the concept we have learned so far, and we'll be doing one hands-on. That means we'll be doing one practical. So here we'll be implementing one text classification model. So in this video, my main objective is to show you how we can prepare your dataset for the model. That means how we can apply all the preprocessing technique, how we can apply these kinds of text vectorization techniques so that you can use those data, okay, for the model training. But model wise, actually, I'm not going to use a large language model as of now. I'm going to use simple machine learning model. Later on, I will also show you how you can use large language model. Okay, because it's the like very initial phase we are doing. As of now, we haven't learned about the LLM. That's why I'll be using simple machine learning model. So let's open up our Google Colab and let me show you the text classification practical there. So guys, as you can see here, I already prepared one notebook for you. And the dataset actually I'm going to use. So this is the link of the data. So the dataset name is IMDb movie review dataset. So this dataset is having 50k movie reviews. So you can download this data from the Kaggle. So Kaggle website, it is available. So it is having reviews based on the sentiment, whether this reviews is a positive or negative. Okay, so it's a classification problem statement. So I already downloaded the data. I have already given the link. You can download the data. So let me upload the data here. So I'll just try to upload. So this is my data. So here, let me upload it. Okay, my dataset is uploaded here. Now, the first thing what we have to do, we have to import some of the libraries. So here I've already listed down all the libraries you need for this experiment. So I need NumPy, Pandas, Matplotlib. Okay. Then I also need test split, counter vectorizer, TF-IDF transformer. Okay, so everything I have just imported here. And as of now, I'm not going to use this keras. So let me just remove it. It's not required. So here I already told you I'll be using simple machine learning approach. So I don't need to use any kinds of deep learning library as of now. So fine, you can see guys, I have imported all the required library I need, and definitely I will explain whenever I will use it. I'll tell you, okay, why we're using this particular library. Now let me import all of them. I think NumPy and Pandas we already imported here, so I don't need it. I can delete it. Now you don't need to execute this line because here I have my data in my Google Colab. You can see Google Colab space. But if you have your data in your Google Drive, that case, what you can do, you can mount your Google Drive. So I'm not going to execute this line. So directly I'm going to assign my data path. So I'll copy, and here I'm going to mention the path of my data. Okay, so let's say this is my data path. Now I'll execute. Now I will load the data with the help of Pandas library. Now see guys, this is the entire data you are having, and here you are having the this one, your reviews as well as the sentiment of that reviews. Now if you want to see the shape, so here you are having 50,000 movie reviews and 2 columns. Reviews and sentiment. Now see here, I don't want to take all the data because again, if I'm taking all the data, it will take lots of time to process. So I'll only take the 10,000 example, okay, from this 15,000 example. So here you can see I'm taking only 10,000 example, first 10,000. And now you can see this is my data. Now if I show you the data shape, now see only 10,000 example I have taken. Now if you want to see any kinds of reviews, you can also check. This is the first reviews. Now, if you want to see the sentiment value count, that means how many sentiment it is having. It is having 2 sentiment, positive and negative. You can see. So positive sentiment is having around 5,000, and negative sentiment is having around. It is also more of around 5,000. You can see 4,972. That means it's a balanced data. Okay, we don't have any issue with the data. Now let's see whether it is having any missing value or not. For this, I can use isNull function. Now see, there is no missing value. Now let's see any duplicates is there or not. So you can see we are having 17 duplicates. What I can do, I can drop the duplicates. For this, you can execute this line of code, drop duplicates, and in place is equal to true. That means you want to permanently delete the duplicate. Now if I execute, now see, there is no duplicate data in my dataset right now. Now let's perform some basic pre-processing. So as I already told you, inside basic pre-processing, you can perform HTML tags removal, then lowercase operation, stop word remover. So these are the things you can perform. Now see, from my previous notebook, that text preprocessing notebook, I have taken the same function, that removes tag function. That means it will remove all kinds of HTML tags from the data, because if I show you the data, it is having lots of HTML tags because it's a extracted data from the website, right? So let's apply this function. I will apply on top of the reviews. So it will remove all the, let's say, HTML tags. Now see, this is the clean data I'm having. Now see, there is no HTML tags present inside this data. Now the next preprocessing technique will be performing the lower casing operation. So let's perform it. So here you can see I'm applying lower casing. Now if I show you, see, all of my word has become lowercase right now. Fine. Now what we'll be doing, we'll be removing the stop words, because as I already told you, so stop word doesn't have any kinds of meaning in a reviews whenever you are performing any kind of sentiment analysis, because it will see the positive and negative words, okay, to differentiate whether this sentiment is a positive or negative. So here you can see here I've written a lambda function, so it is doing the same thing. You can also use the previous function I showed you in that notebook. Either you can also follow this particular approach. Okay, so here I'm using lambda function, and lambda is a one line function. Okay, in the one line I'm taking all the word one by one, and if any stop words is there, okay, I'm just trying to remove that stop word with the empty space. That is the idea. Now let me execute. Now see, there is no stop word present in this data right now. Fine. Now let me show you my head of the data. Now what I have to do, I have to just separate out my x data and y data. That means my independent variable and dependent variable. So independent variable means this is the review one, and dependent variable means this is the sentiment. That means this sentiment is my label right now. So I'll store inside x, and label I will store inside y. Now this is my x. That means the entire review, and this is my y. That means my sentiment. Now one issue you can see, sentiment is nothing but it's a text. Okay, it's a text. You can see it's a string, but what I have to do, I have to convert to the numerical representation. So here I can simply apply label encoder. So it will assign positive with 1 and negative with 0. So let me apply. So for this I'm using label encoder from sklearn, initializing the object, and I'm feeding my y data. Now see, your data will become 0 and 1. Okay, that means it has converted to the numerical representation. Then what I have to do, I have to perform the 10 test split, because I have to keep my data for my training as well as the testing. And the test size is I have given 0.2. That means 20% data I'm keeping for the testing, and 80% data I'm keeping for the training. So let me perform. Now this is the training size, and this is the testing size. Fine. Now I'll be applying first of all bag of word. Okay, I already taught you the bag of word. I think you remember. So I can use the counter vectorizer for this. Now I have to apply the bag of word on top of my reviews. Okay, reviews is my like input data, right? Then I'm also performing on top of my test data, because I'm having two kinds of data, training data as well as the testing data. And I think you know, whenever you are performing on top of training data, you have to use feed transform, and whenever you are performing on top of a testing data, you have to only use transform, okay, math function for this. Then I'm converting to the array representation. Now this is my training vector, and if you want to also see the testing vector, this is your testing vector. Okay, now here we'll be using one machine learning model called naive Bayes. Inside naive Bayes, we're having one naive Bayes version called Gaussian NB. Okay, Gaussian naive Bayes. We'll be using this particular algorithm. So here you can see I'm feeding my data, so x train and y train. Now let me train my data. So here I'm only showing you how we can pre-process your data, how we can prepare your data for the model training and all. But going forward, here we'll be using actually transformer based architecture. Okay, that means large language model we'll be using here. Now this is the training I have done. Now we'll be doing the prediction on top of my test data. Then we'll be calculating the accuracy score. Okay, now let me execute. See, this is the accuracy score I'm getting if I'm using Gaussian NB, and if I'm using bag of word, okay, bag of word technique. So I'm getting 63% accuracy. Now you can see this is the confusion matrix. Now if I'm applying random forest classifier on top of it, so now let's see the accuracy I got. So guys, you can see after applying random forest classifier and I was using bag of word, I'm getting this accuracy, 84% accuracy. Now see, we'll be using bag of word only. Now instead of see taking all the features, what I will do, I'll take maximum features 3000. Okay, now you can ask me what is maximum feature 3000. I think you saw the entire corpus, right? I already told you the corpus. Okay, about the corpus. Corpus means the entire data. And from the entire data, I'm only considering 3000 unique word. Okay, 3000 unique word, 3000 frequent unique word. Okay, this is called maximum features. because see, I don't need all the features, because if I'm using all the features, my dimension will increase, right? And I don't need to increase my dimension. Okay, if my dimension is increasing, that means my model will get more complexity, right, to perform the prediction on top of it. And here I'm using a machine learning model. Okay, I think you can see. So that's why I'm taking most frequent 3000 maximum features instead of taking all the features, right? Now it will create 3000 dimensional space. Okay, 3000 dimensional space instead of taking all the unique word, right? Now see, again I'm performing the bag of word operation. Now again I'm taking random forest classifier and I'm training and checking the accuracy. Now if I execute, so you can see this is the result, but this result is not good enough. So we are getting closely related accuracy only if I'm using all the, let's say, features, and if I'm taking 3000 features, the accuracy I'm getting, it is almost same. Now let's try with n-grams, because I already told you about n-grams, right? What is n-grams exactly? So here let me pass the range of 2 to, because I want to consider a pair, okay, pair of word. That's why I have given 2 to. That means it will consider 2 word, okay, as a one pair. That's the idea. And here I'm only taking 5000 most frequent word. Okay, now again I'm performing bag of word operation, then random forest classifier, then I'm calculating the accuracy. Now let me show you. So guys, you can see this is the result actually I'm getting. So now in the summary you can see your like bag of word is working fine instead of taking the n-grams. So in some case actually bag of word will work fine, in some case n-grams will work fine. It's completely experimental things, okay, you have to perform. Now let's try with TF-IDF, okay, TF-IDF technique. So here is the TF-IDF code, I think you remember. So first of all we have to initialize the TF-IDF, then I will apply on top of my data, okay, training data as well as the testing data. So it will give me the vector, and again I'll be using random forest classifier to train the model, and I will show you the accuracy score. Now see if I show you the accuracy. So here we are using machine learning model, that's why performance is not good. But if you're using any kinds of deep learning model, you will see that your model will perform good. Now here you can see this is the performance of the, now you can see this is the accuracy I got. So here I showed you almost all the vectorization technique we have learned. But one thing I want you to explore, this what to vec one. So I already shared you the code of the what to vec. So what you have to do, just try to apply what to vec, get the vector and try to train with random forest model and just observe the accuracy. Okay, so this should be your task guys from my side, because unless and until you are not doing anything, things would be much difficult for you to learn, right? But if you're practicing by yourself, I think this will help you a lot to learn any kinds of topic. So yes, this is how actually we can perform the text classification with the help of machine learning. And that's how actually we can perform the data cleaning task like data preprocessing and text representation. Okay, everything we can perform like that. But again, I'm telling you guys, this is not an actual way we create our application. This is just a basic introduction I have given, like how we can like do the data preparation. Okay, this is my main objective. Now in the next video, we'll be learning about large language model, like what exactly this large language model and how this large language model got trained. Okay, everything we'll be trying to discuss. So with that guys, thank you so much for watching this video, and I will see you next time.